Datum is forward. Okay, so here's our problem here. We've got a whole bunch of items they've given to us. But at the end of the day, we're asking, what is the empty weight center of gravity of the aircraft described above? So this is actually two problems kind of in the same problem. So we'll take it in two steps. So first, we're going to take this. So it says the datum is forward of the aircraft's main center point, and that's going to be 30.24 inches to the main center gear. The actual distance between the tail gear and the main gear center points is 360.26 inches. Okay, so we have a right main and a left main. The right main is 9,880 pounds, and the left main is 9,800 pounds. And the tail wheel is 2,100 pounds. So we have to understand that this is what's considered a tail dragger aircraft. There's two main wheels in the front and one smaller wheel aft in the rear towards the end. So it's not the tricycle configuration that we may be used to seeing. It's like an older style configuration. But that being said, okay, so that's one problem. So what you've done is this is what you will do for weight and balance. I've drawn the tires here offset, but they're actually like one right behind the other one, but I just drew it to where you can see it like that. These little boxes are representing the scales. So what you've done is you've configured the aircraft correctly, like we talked about in the last problem, and you've rolled it up onto these scales. This scale on this side, this is your left, that would be your right. Everything is from the pilot's point of view in the pilot seat. So when you're sitting in the pilot seat, the left would be this front wheel and the rear would be the right wheel. So we're saying the left main gear is 980 pounds. Sorry, 9,880 pounds. And the right is going to be 9,880, and the left is 9,800. And the tail is 2,100 pounds. So we put it up on scales, and what we need to do is figure out our center of gravity with these weights. So what we do is we need to find our arms for these configurations. So that's the trickiest part of this problem. So let's go ahead and look at this. The datum is forward of the main gear by 30.24 inches. So here's our main gear. And remember, they are actually just one behind the other. I drew it so you could see it like that. So that'd be 30.24 inches from here to our datum. Our datum, again, is just our starting point. It's our 0 point. That's set by the manufacturer. They decide where they want to put the datum. Okay, so we know that, but we know the actual distance between the tail and the main gear center points. So from this center point to that center point is going to be 360.26 inches. All right, so that being said, the actual distance from our datum, because everything is measured off of our datum, is going to be 390.5 inches. So when we're doing our arm, when we're doing our WHAM equation, we need to make sure that we're using this number for our tail gear. All right, so let's go ahead and first do the first part of the problem, which is the weight and balance calculation without any of these other laboratory water, hydraulic fluid. So we have weight of 9,880 times 30.24. And that's going to give us 298,771.2 moment. Our second scale is going to tell us 9,800, and that has the same arm away from the datum, this distance from the datum to that center point of that scale, or center point of that wheel, actually. So we'd have 296,352 to that point. And we have 1/3 scale where the third landing gear is, and that's going to be a weight of 2,100, and that's at a distance of 390.5 inches from the datum. And that's going to give us a moment that we have to multiply these two numbers together. All right, perfect. So we are looking for this arm, right? So we don't use the middle column. That's what we want. So we add these up here, and we'll get 2,000 21,780. That's the total weight of this aircraft. That's how much this aircraft weighs. We put it on scales. We found that weight. And then we're going to calculate the moments of those 3 scales from that datum point. And it comes out to a total of this large number. All right, so we know we're just going to use wham again. So we're just going to do the same thing, wham. So at the end of the day, to get the arm, we're going to divide by the weight and divide by the weight. So the arm is equal to the moment divided by the total weight of the aircraft. So we are going to have A equals 1415173.2 divided by 21780. And that's going to give us a center of gravity of 64.98 inches. So what we did is found our center of gravity. If we had configured everything properly, that would be where our center of gravity was. It would be 64.9 inches from the datum, but we didn't have it properly configured. We left some things on there that we should not have. So we're going to have to do a second calculation. So we're going to go ahead and do wham again. So we do know that we have a total weight of this aircraft is 21,780 pounds. We know that has an arm of 64.98, and it's going to give us a moment of, it's the same moment from up here, 415,173.2. Okay, but what we need to do is subtract off those items that we don't need. Or we have to figure out. Okay, so we have to look over here. We have a laboratory water tank full. Okay, so we need to remove that weight. That's not part of the empty weight. So we need to subtract 42 pounds, and it's located at fuselage station 335. All right, so that will be a total of a negative times a positive is a negative. All right, there's our total moment for that item. Then we had hydraulic fluid, 45 pounds at negative 18. So we need to understand that the hydraulic fluid is part of the empty weight, so we don't have to do anything for that. But we have a removable ballast. So we need to take this ballast off because it's not part of the equipment list. If it's a removable ballast, it won't be on the equipment list. If it's a permanent ballast, then it will become part of the equipment list. But this is a removable ballast, so we need to go ahead and subtract off that weight. And it's going to be a negative times a positive again. So we have our total here. So we need to do the same thing. This is what we're solving for, so we're not going to use that middle column. So we're going to total these up. It will come out to this large moment. And this times this is going to be 21,616. So to solve this equation, we're going to divide both sides by 21,616, 21,616, and our actual empty weight center of gravity, or this A, is 62.54 inches. And that would be our empty weight center of gravity would be 62.54 inches. So after we remove these items, our center of gravity did shift some.